Hi. Okay, so today my goal is to simultaneously make life easier and harder for everybody in lock sport. I'm going to show everybody how to make the type of challenge lock I was showing off on the subreddit a little bit, where there's a massive, evil, dirty undercut made with a piece of brass tubing. So these are the tools you're going to need. You're going to need, your core, your lock. You're going to need a piece of that tubing. Now, this tubing I originally bought to make a follower out of, and it worked pretty good for that. It's a little undersized to make a follower, but that doesn't actually matter that much, and it also turns out not to matter that much for making a challenge lock out of either. I originally thought it did, but the fit doesn't matter because you have to cut a split in it. We'll get to that. We'll deal with all that later. So you'll need that. You'll need a clamp. You'll need drill bits. This is my pin vise. I use this for stuff that's too delicate to use power drill on, which is great for that. You're going to need some way of cutting the tubing. I was doing this with just one of those rotary wheel tubing cutter things that look like a C-clamp, but it bevels the edge, and I'm going to try cutting it with this saw in this little miter box in the hopes of getting like a nice flat non-beveled edge, because that'll work better when everything's assembled, although it worked pretty good not doing it that way. But so you'll need that saw. This is a razor saw. It came with this little miter box for it. I got this at a hobby shop. You can just use a hacksaw. I actually may end up doing this by installing the tubing I want to cut in the chuck of the drill, and then using the chuck's face as the one edge for the saw. I might end up doing it that way instead of using this. We'll see how it works out. You will also need some files. Principally, you need a half-round file and a flat file. This file, you need it because one of these two edges isn't cutting. Like, it's only got a cutting face on one of the two sides. And you need that so that when you're doing your filing, you can put the non-cutting edge up against there so that you don't file away that face, because you don't want to do that. That needs to stay where it is. So you need that for this, whereas you need this to get a nice proper edge on the other side. When you're filing and the thing is spinning, if you have a less than 90 degrees facing edge into the cut, you end up with a pretty close to 90 degrees like jam on the side of your cut. We'll get into that when it matters. Yeah. You're also going to need a power drill, which isn't pictured here because it doesn't fit here with all the other tools. Now, there are two ways of doing this. Style one, you put it in the drill. I'll show it properly when I'm showing it. You put the whole core in the drill, and then you spin it and file away, like as if you're using a lathe. You file away a narrower section that your sheath fits over. And this is a very precise method. You got to pin the sheath in place. But then it's solid. You end up with very precise fitting. This is a good method. This makes for a very difficult lock to pick, and it's relatively easy to do in terms of like what you're doing with your hands. None of it is really all that difficult, but there's quite a few steps. This is more complicated. Both of these methods need hand fitting, and the real downside to this one is that you can't do the whole core because you need to fit the core in the chuck of your drill, so some of the core is going to be in the chuck and you can only get the first couple of pins. So that has its pros and its cons, but this method is pretty good. This is how I did the lock that I sent to Bosnia and Bill. Bill, if you're watching this, don't watch this. Whatever. I don't think Bill watches my channel. I would be shocked to find out that he did it. Anyway, yeah. This is how I did the lock I sent to Art of Klein. This is completely different. You don't even need to use the power drill for this. What you do is you just file a flat across the top of your core, and then you cut like a semicircle cross section out of your piece of tubing that fits in the flat slot you cut. Now, this method is easier to do, but requires more hand fitting. Now, I'd say it's easier to do, and easier is the wrong word. It's less complicated to do, because there's really only like a couple of cuts. They need to fit more precisely, and so that requires a lot more, filing and fitting and checking, and there's more of that to this method, but this method has several more steps involved. So there's pros and cons for both. When it's all together, this one fits together a little bit sloppier, which some people might argue is better, but in terms of what I'm trying to do with the copying Ruko's method, this one probably copies it a lot more closely, whereas Style 2 is easier to do. They both make for a very difficult to pick lock, but the difference being of the two locks that I've already made. Now, the lock I made this way was built out of a Schlage, the lock I made this way is built out of an American. Americans are just easier to pick in general for various reasons, but I could not pick this one at all. That one I was able to pick before I sent it off. So, it is several grains of salt to take all this information with. That's why one of the reasons I'm doing it again with 2 American cores. The other reason I got my hands on some American cores, so that's one of the reasons. There's several reasons, but these are the 2 methods. I'm going to go over them both. They both have their pros and cons, so I'm going to try my best not to draw. I prefer this one. I'm going to try my best not to draw conclusions, though, and let the audience, but I prefer this one. But I'm going to let the audience pick theirs. This one's probably more fun to do because you can just sort of do it sitting in your lap with hand tools. This one involves a lot of getting up and putting, you know, different things and different clamps and power tools. I guess it depends on what mood you're in. When it comes to how easy is it to pick the lock when you're done, the answer is this one is harder so far in my experiments. So that's part of why I prefer it. But anyway, we'll see you on the next cut. There. Okay. So here you can see what I'm talking about. It fits in the core, or the core fits in the chuck. And let me just tighten this up. Now this is the difficult part because it's too loose and it slips out too tight and your core is damaged permanently forever now. So you gotta be kind of careful. You know, what does it have? It says click there. Okay. So that's actually probably not tight enough. So he's better at doing that than I am. But you can see there how I've tried to line it up. It's kind of hard to see my camera screen here. You can see how I try to line it up. I managed to get 4. You can see how I lined it up there so that the edge, the front face of the chuck itself is going to be one of my guides. And I'm going to have the file touching that edge so that I can't cut too far inwards that way because I'll interrupt the other pinhole. The proper word for that, I forget. But I'm going to use this edge, this piece of material here is going to be one edge that I'm up against with the side of the file that can't cut. This piece of metal is hardened, so I'm good to touch that with the cutting edge of the file, and that gives me my 2 square edges. Hopefully. Okay, so I've got a little bit done. Oh, this, I can't really, trying to film outside, I can't really see the screen on my crappy little camera. So I got a little bit done. And that's just done with the flat file. Again, with the flat edge up against here, so that I can get as close, like a nice edge on the part on both sides. I can't take it out of there because the annoying part of the way that I'm doing this is because you can't take it out of there and some of it is inside of it. You can't really check as you're going without disrupting the one guide. So that's not the best. But here's what I do. I've got a random piece of tubing. This is actually the other diameter of tube, but this one's the diameter for a Schlage, but that doesn't matter. The thing about this tubing is that they're the same depth. So this is my depth guide. I bring this up against the edge here, and it's... Can I get any of this on camera? Hopefully you can see, and I'm like, this is my depth gauge. And once it starts getting really, really, really close, then I can take it out and risk it. And that's how I get this done. And so this part is a little fiddly, but it goes by quicker than you think because this drill is pretty fucking strong. And so what you do is you just run the drill full bore and basically hold the file against this, and it does its thing. I'm going to show a little bit of that, but it's hard to get on camera because of how I got to hold everything right in front of the camera, and it's in my lap, you know, it's not the best. I can't really do it through the camera either, so I gotta hopefully get it aligned so that you can see. Awesome. Alright. So I'm not gonna do a whole lot on camera, I'm just gonna basically demonstrate the idea. So you always check, you got hopefully you can tell the difference on camera that this side doesn't have teeth, but this side does. Hopefully. I don't know. Here. Versus... Oh, it makes the same noise. Well, it's kind of rough, but it doesn't actually have teeth on the one edge. Anyway. Let's try to get... And this is just in my lap. That's how I'm doing this. There's probably better ways to do this, but it works. then you give it, oh, I drifted off camera there, and then you give it a little check with this. It's getting closer. As you're going, what'll happen is it'll taper. It's very difficult not to do that because I don't have a fixed guide to work off of like a real lathe. So that's one of the reasons why I then switched to the half round, because with the half round it's easier to bias the other way. And so you just kind of, you'll naturally bias the one way with the one tool, then you bias the other way with the other tool on purpose, and you try to keep it as even as possible. That's pretty much the easiest part of this process to mess up. So I'm gonna demonstrate with this tool a little bit for the camera, and then I'm gonna turn off the camera and actually do it, because it's like awkward as hell to do on screen. Alright, it's probably not showing up on camera, but I've actually got a fair taper going the other way now, and then I can work the rest of it down to the low spot on that taper. And because of the way it's tapered, you can't really, like, if I put this in there, it's actually still not deep enough on the tapered end. But, you know, it's, you go back and you go forth, and then you just keep checking, and, you know, that's that. Now, you'll see more when I do the second method of doing this. With the second method, that process of doing a little bit and checking your fit and do it, you got to do that more. With this is pretty much the only time you do that. With the other one, you got to do that like on all four faces of the cut plate to make sure that they fit evenly. So there's more of doing that part. So your definition for you, which one you think is easier, is basically going to be determined by how willing you are to put up with that fiddliness. But anyway, I'm gonna move forward here, so I got to switch off the camera to get her done. I'll catch you guys when we have more progress. Okay, so I'm not quite done yet, but what's happened is while I was doing this, it slipped out of the chuck because there was like about 2 millimeters of material inside of the chuck. And so I was a little ambitious with the 4, but that side is the side that there was less leverage on, so it's actually the correct depth on the back end of the lock, and I just need to sort of even it up on this side. So I'm going to keep pushing forward, but realistically speaking, I probably should have only tried to cover 3 pinholes instead of 4. But I pulled it off. Just got a little shaky, and my bit's landed in an anthill, but we're good. We're going to keep going. While it was off, I checked the fit, and so like I said, it fits up okay. Actually, I can probably take her out of here. There, let me just quickly demonstrate, because the fit doesn't matter anymore. There. So, getting this on camera. Doing this in the semi-shade. Okay, so this thing fits on there really easily because it's too big, and when I put it over here, fits quite nicely, but I can literally feel that it's still tapered. But over on this side, you can see that fit is pretty good, and that's what you're looking for there, is that nice fit right there. And so it's not going to fit around because it's the wrong size, but I'm just checking the thickness of this tubing, because that's what you're trying to cut away, is that thickness. It's all focus. Yeah, this is the nightmare of focus. Anyway, I'm gonna keep going. We'll get better pictures of this when we're closer to done. Alright. I think we're recording. There. This is what we're looking for. This is what we're looking for. Oh man, it is so hard to see my camera screen in direct sunlight. I hope this video is turning out okay. I won't know until I try to do the editing. So this is what we're looking for, and you can see that the fit. Hopefully, you can see that the fitting is where it needs to be. There, we're just the correct amount of thickness. Maybe a little less. It's okay for it to actually be a little less. Like where this cut is deeper than it needs to be. That's actually okay. And it's pretty good. It might need a little bit of touch up in the edge there, but it's feeling okay to me. And that's what we're looking for. It doesn't even actually need to be smooth. It just needs to be pretty even all the way down. Oh, it's so hard to see what I'm doing on camera. And so that's how I check the depth there. You can sort of see. And again, there's some things that you won't be able to not do. Like there's a little bit of ramping, and there's a little bit of a ramp down in this piece here, and so that's kind of hard to do much about. You can go in with like a hard edge or a saw or something. You got to sort of cut a groove in to deal with that, which I might end up doing if I need to. but should be okay. And so there's still some more work to do on this core, but that's actually not that bad. You basically just, you gotta cut a little flat across the top of these to make a gap, to make a gap underneath the tubing when it's installed, the sheath. Because as it is now, there's not really any gap at all. It's just right up against the edge there. So that'll give you like 2 shear lines, but what you want is a gap in there to catch the pins. So I still need to cut that flat, but I'll do that later. That'll get on camera, hopefully. Anyway, on to the next bit. Okay, this next step is in fact magnificently simple. What you do is you clamp your core up in a clamp, preferably one like this that sits flat, and then you file a flat across here. Now this flat doesn't need to be very deep, it doesn't need to be very far down, it just basically needs to be, you're going to make spools, and those spools will have like the sort of shelf on them. This gap basically only needs to be as wide as the depth of that part of the spool. The more it is, the more wiggle room there is, but I have very short key pins under here, so I don't want to cut it as long as the whole height of those key pins, because then they'll like jiggle loose in here and I'm worried about them turning sideways inside the lock. So the goal is to not give enough room for that to happen, so you only really want like, you know, a couple of millimeters, nice flat there. It's just so that there's some airspace underneath the sheath when it's installed. So that's easy, you just file on here, be very careful about your edges, you don't want to drift too far in either direction, so what I'm going to be doing is using the non-cutting edge of my file on whichever side I'm up against at the time. So I'm going to do a little bit on camera, and then, you know, the rules, I'll turn it off and finish it up. So, a little bit done here. Again, you always, I'm paranoid, so I'm always double checking the side that I'm using. This also doesn't have to be tremendously flat either. I mean, it helps, but the edge that needs to be sharp is the underside of the sheath, which is going to be sharp because of the fact that it's a piece of brass tube. So this flat doesn't need to be super flat, it doesn't need to be super sharp on its edges, you know, this is surprisingly not precise, this particular cut. But I want to try to get it as even as possible, which kind of involves putting like biased pressure as you're going to even it all out. Again, if you're doing this with like real machine tools, none of that would be necessary. It'd be like, you know, your CNC cutter does this perfect with like an end mill, but no, we're trying to do this cheap and easy, and it's slower, obviously. It's harder to do multiples that are all exactly the same, but when you're doing this by hand, it's not actually super crazy difficult. It's not undoable by any means. So I'm probably going to be able to just finish this whole step up in between muttering about it. And if I had clamped it further this side in the clamp, it would be easier to get at with the file, but this clamp is cheap as fuck and goes all ski-whiff if you do that, so you gotta keep it in the middle. You can see it's already a little ski-whiff anyway. It's also kind of hot in the garage, but that's not a big deal. That's looking pretty good. I think it's a little angled. Yeah, a little bit probably. But that should be okay. Yeah, close enough. Alright, that'll do. Again, like close enough is close enough. That actually is an attitude that is surprisingly effective with this technique. Anyway, I'll be back with the next step. Alright, so here's that next step. Oh, I cannot see the screen. Oh, alright. Kind of visible. I'm at a weird angle relative to my camera. Okay, so the next step, because there's gonna be some more test fitting involved. The next step is to measure and cut a piece of tubing that exact length. So you could do this with measuring and marking and all, but I'm gonna file the edge of it anyway. So I'm gonna kind of eyeball it and just try to cut it roughly a millimeter too long because I know I'm gonna need to cut that back. Which is the lazy way of doing it, where I'm kind of making more work for myself, but that's alright. So what I'm gonna do, put this in here, sort of line them all up. Get my saw. Like I said, if anything, I want it a little bigger. It's sort of just the rule when you're not measuring shit, is you make it a little bit bigger and then you file it to fit. So, I'm trying my best to do that, lining everything up here. It's probably pretty far off, but again, now that I've made that mark, I'm going to flip it around to the easier to cut way of doing this, because obviously, Alright, so the place that I've selected to film doing this is kind of, it's not even really framed very well. The place I've selected to do this is kind of awkward to do this, so you get the idea. I'm going to go do this somewhere solid and be right back. Alright, so I got her cut. What ended up happening is she sort of spun around while I was trying to cut her in there, but that just did a groove, and then when I actually held her tighter, it went through pretty quick, so it's not so bad. Not the cleanest cut, but that's actually not such a big deal. If it was long enough to fit in the chuck of the drill, this would be easier to do, but that's not a big deal. With the half round, you can use a round file too, but the half round fits nicely. Just sort of clean that up a little bit. You know, it's not too bad. I should go get my round file, actually. That would fit better because it's the narrower tube. It's weird, your muscle memory remembers, like, the other stuff fitting. Anyway, it's probably not really muscle memory, I'm just stupid. But yeah, you just sort of give that a nice, that's working okay, you give that a nice roll around, it clears up that edge, you don't really want the sharp edge in there. Also, it'll sort of turn any, like, loose, flaky metal so that it's pointing straight out rather than being turned onto the inside. That's good. Then you just want to sort of, get that off right there. There you go. I don't know if that flake is turning up, but it just cuts the flake right off. It's not bad. This part's easier if it's long enough to fit in the chuck, because you just put it in the chuck and go, and then you're good. But whatever, you know, it's nice. You know, in tune with the machine, or whatever the hell people say to themselves when they do it this way. Because yeah, I'm not necessarily saying that this is easier or faster than doing this with quote-unquote proper tools, because proper tools is like a tiny lathe and the machine shop tools, and you would just do this. That, like, really ultimately proper tools would be a CNC mill, and you just make all this from bar stock and laugh. But over here in the real world, nobody's paying, like, tens of thousands of dollars for a tool to do one thing for for their hobby, so this is how to get it done by hand. And again, like, the goal here for me is to prove that this is in no way impossible. Like, I've seen locks in people's YouTube videos that are built with these kinds of principles where it's clear that they used ridiculously high-end tooling to do it. And that's not the only way. You're not out of luck if you don't have access to that. Like, I don't even have a Dremel. I don't even have a Dremel tool when I'm doing this. Like, it's totally within your grasp. Doing it without damaging your nails, impossible. But that's fine. Doing my nails is the other hobby, so, you know, I do one hobby to do the other. Oh, no! That's fine. I'll get that out of there. Okay, anyway, I'll cut this until I find that. Be right back. Okay. Oh, I can't see the screen. Okay. So, okay, I got it. And this is the fit that you're checking for. You want it to fit in there. It doesn't quite sort of does. There's more room to file it down. I'm just giving you the idea. It fits on one side. But that's what you're looking for. You want it to fit, and I'm going to keep going until it goes all the way around. Actually, I might be able to just do it right here. Pretty much there. Again, it's easier to keep it flat if you're doing it in something that rotates, but again, also isn't super necessary either, as long as it's close enough. Take that edge around there off as well, just so that because that'll bind up inside the lock when it's assembled. There you go. It's nice. It's perfect. And I know what you're thinking. You're like, wait, but how? How does it? This is why it doesn't matter so much if things don't fit super snugly. You got to saw this in half, not straight in half. You just got to split it on one end. That's surprisingly easy to do. Get that in your clamp there. Try not to damage it too much. Obviously you want it sticking up off the face of the clamp a little bit. Get your saw. Get your saw. I can use my thumbnail, but you just want to start on one side. You just want to get like a little angled cut in on one edge, and then that'll guide you on your way through. This isn't like 100% square, it's again not the end of the world. You're going to file inside of there a little bit anyway. And I'm not flat down on the tube, I'm at an angle like this on the tube, so the cut itself is going to guide me through the tube. This is the most way of doing it, but yeah. You can hopefully see the cut is only on one end, and I'm coming at the tube at an angle like this, rather than flat down. I'm coming at it at an angle, and that way my cut travels through the... This is what you do when you don't have proper guides for things. So I'll be back when the cut's made. Alright, so we split her in half. Then the cut still had rough brass inside of it, so what you do about that is you take your triangular file, put it on the inside, one of the edges into the slot. Just give that little file like that, you sort of rock it around a bit, knock all that crap out, give it a little bit on the ends. Just want to get rid of the sharp edges, you know. Just want to make sure it all fits easy and it doesn't cut you while you're playing around with it. Just stick the point of the triangle down into the slot there, just to file it out. You might end up having to cut this wider, either by making another slice or just getting a flat file in there and going at it, but maybe not. But this is the part where we get to do the test fitting. Now again, it doesn't super duper want to go in there easy, so I'm just going to pry her open a little bit. And there's going to be a whole lot of deforming and reforming and beating things back into place, so the getting a little deformed now is by far not the end of the world. Just going to spread that a little, see if I can get her on there. The Schlag was so much easier for this part, I don't know why. Alright, come on. Actually, to be fair, the tubing I started with was wider for the Schlag, and I do know why. Yeah. Hang on. There we go. I'm doing this to try to force it open a little bit. That kind of helped. This is why you want to knock those sharp edges off on that side. There we go. That's nice and tight, but that's not the part that matters. I have a little screwdriver that's perfect for this, and I didn't bring it here. There we go. Oh, is it going to fit? Okay, so this is the first real test fit. Doesn't look like it wants to go. Oh, it did. It snapped right into place there. Or did it? No, that's going to be a giant butthole to get off of there because it's still a little tight. I probably need to take a little bit off on that inside edge a little, but it fits in there pretty nicely. Now, It might go in the core anyway. Let's give her a shot. It's gonna... We're gonna... No. No. Yeah. Alright, so it needs more test fitting. Still, I guess. A little bit more judicious filing. I might have to chuck this thing back up, but that's alright. Ah! There we go. It went in. Perfect. Okay, that's good, because I can demonstrate the next bit. For drilling the holes through it, it's not aligned yet. You get everything aligned, and then you drill those holes through here, and at least the pilots. And that way, when you're actually doing it, you know they're going to meet up and align. And I'm probably not going to be able to get on cam. My battery's already fucking gone. Oh, this camera sucks. Anyway, so you drill the holes through those guide holes. On the Schlage, I took the top plate out, and I drilled it through there for even more guidance, and that's what you want to do when you drill through the plate to make your holes. I will hopefully get that on camera, but I just wanted to explain that here, where you put it together assembled, and then that's how you do that. The way that I align that, this is going to be fun. Okay. Oh, perfect. Okay, the way that you align everything. Now, this is going to be awkward on the one that doesn't have any hole, like the one that's going to cover the whole thing. The other one's going to be a little different, but here, hopefully it's showing up on camera, not all the holes are covered by the plate. So I just have a piece of brass rod. This is what I cut security pins out of. Kind of get in there. There. You shove that in there, and now it can't fall out of alignment. You drill your pilot holes through the plate, and you don't want to go too deep because you don't want to drill into the core, but you just get your pilot holes popped into the plate, you take it out and finish them. And that's how you get all your holes nicely aligned with everything. That's how I do it. And that's been serving me quite nicely. Just get a nice big piece of rod in there. Now, you don't want it too crazy long, so you can't get in there with the drill. This is about the right length. And it locks the core in place, all assembled, and that's how you drill the holes. So again, I'm going to try to get that on camera, but if I don't, that's the explanation for how to do that. Alright, now's probably the worst time ever to bring up the fact that I was wrong earlier when I said 7/64. Okay, so the size drill bit that's for this is totally not that. It is 3/32 of an inch. Whatever. You try all the ones in your kit until you find one that fits down into the hole properly, like that. See, that's what you're looking for. But I got it all aligned, which was sort of a feat. This sheath friction fits on there a hell of a lot better than the one I did for the Schlage, because this tube started out a little narrower than that. But that's all good, so that all fits in there nicely. It's nice and tight. I might not need to pin it in place, but I'm probably going to anyway. Aligning it is having the gap across the bottom where the gap for the key is. I found that to be quite useful. And so I got it all aligned, I've got it inserted in there, I've got the rod holding everything in place, and I'm going to do the pilot holes. I might go most of the way through. I find it easier to just sort of get a nice guide and then do it by hand, like not assembled, because I don't want to damage the core. If I have to cut a new plate, that's not a big deal. If I need a new core, then I need a whole new core. So I should probably be clamping this up, actually. Hang on. Get this all clamped up. Got her all clamped up. It's on camera, hopefully. Wrong way. Alright, that was a hell of a lot quicker than I expected it to be. Alright. Alright. It's probably going to be harder to get out now. No, not that hard. Alright. And there you go. That's, how you get those cut. Not too bad. There's going to be a lot of cleaning up left to do, but that's how you do that part. That's the part that you think is hard that totally isn't. Okay. So, I just saved you guys having to sit through like 45 minutes of filing and checking and filing and checking. A big one that's worth pointing out is once you've drilled the holes, they need to be like dressed up a little bit, and I use this to make sure that it fits through the plate because this is the same size as my pins. So I just pass this through the plate, and if it doesn't fit, I give it a little bit more with the round file, back and forth. I skipped over that because it's hard to film and really annoying to look at, so yeah. Unless I was gonna do like cool photography, fast forward, speed. I can't make a how it's made video like that. So it's just gonna be me explaining things. But now it all fits together nicely, and I had to painfully modify this slightly. You got to be careful because once you got the holes drilled, there's very little structural integrity across the top there. But I had to widen it, so now it's not as tight. But that's fine. I'm gonna pin it in place. I figured I would, and I also. Cut these down a little deeper. You can probably see that I managed to get all the way past some of the warding, or into the warding, into the keyway. I don't know, but you gotta go through with the tip of your file and knock the bits in the middle out, otherwise they get jammed up in your lock. But that'll work fine, even though it's cut like a slot like that now. I didn't cut the slot, I just filed a little more down into that slot. That's fine, that's perfectly alright. You can see it all lines up. It blew out one of these holes. That also does not matter. That's fine. It's probably better to have the hole blown out and filed all flat and smooth than it is to have like a jagged edge on that bit with just like a sliver of metal. Like this is probably better. And there you go. That all works. That all fits in there. It assembles nicely. To be fair, the plate, the sheath is stuck when I put it in there because it's like bowed out. But that's actually good. Once it's fixed in place, it sprung outward a little bit. Will actually give you like resistance, kill your feedback a little bit, but that's good. I'm happy with how it fits in there, and yeah, so that's how you do that. This is a master lock, or not a master lock, an American, same diff. This is an American, so this is cheap materials. It's easy to assemble. It's easy to do. It's a bunch of time you got to put into it, but that's we all got time. And there you go. That's how you do that. I will be back with method 2, which is a hell of a lot simpler once I've charged my battery for my camera. But there you go. Again, this is totally doable with very simple tools. So don't think you can't do something just because someone who showed you how to do it had better tools than you. Improvise, adapt, refuse to buy things. This is a good system, weirdly. I'm lying. Okay, so pinning the sheath in place. There's been quite a lot more like little bits of hand filing and stuff like that, getting everything to fit. But here's probably the awkwardest part of doing this, and this is one of the things I was talking about how doing it this way is more complicated. Okay, so what I have done is I have used my little piece of rod there to jam the sheath in place on the core. Then I have used the Bible here to basically just clamp it down so that it can't wiggle around. It's hard to do with one hand on camera. Just squeeze it a little bit. And this keeps it from, because it's a little spring-loaded, it's a little wider now, so it keeps it from wiggling around on there. Now, what I'm going to do is hold that all down and drill a hole. Now, this bit is 5/64 of an inch, and that arbitrary number happens to be the same as this other piece. I'm not doing a good job of this. This other piece of stock I've got, which is a little narrower than that. This isn't necessary, I have it, so I'm going to use it. It's a little narrower than that. And I'm going to drill a pinhole through the sheath, down into the core, sized for that, so that I can just drop it in there, and then I'll file it across so that it's all smooth, and it'll fit back in here. And this is important. This hole needs to be in line with not one of these holes. Because this pin is going to be loose. So if that pin is in line with one of these holes, that means that when the core is assembled, it'll be in line with one of these holes. And if it's in line with one of these holes, it can fall out. And you don't want it to fall out, you want it to stay in there. So, in theory, you could, like, paint it over, you could use, like, a tiny screw. There's, like, a million and one ways to make it like, more permanent. And not have to worry about that, and feel free to use any of those, but I'm going to do it this way so I can take the whole thing apart again if I want to.
and so it needs to be lined up with the space between two of these holes. And so I'm going to line it up between those two, and just drill it probably somewhere down here, a little bit lower than 90 degrees, so that I got more material to work with. And as long as it's between two of these holes, it'll be under this bar, or this bar, when you turn the core, and then it can't fall out. Now, I believe you could cleverly put it at the right place on the clock face that it never goes under there under normal operation, but fuck that, I'm going to do it the easy way. And so that's important, is to not drill it in line with any other holes, so that it doesn't fall out. So anyway, I'll be back when I've got some progress on that to show you. Okay, we are back. Here's how this looks now. I've got this hole here. I probably should have actually drilled that at 90 degrees, but whatever, it's fine. And I have a matching hole in the sheath. And this little guy here fits in there, through there, and pins it all into place. Now this is never happening with the camera in my hand. So I'm going to assemble it, and I'll be right back.